In this course, we'll go over a brief overview of the concepts and installation procedures for Docker to get you up and running quickly. So you don't need to have any prior experience with Docker, as we'll cover the basics needed as a developer. Also, I will be using a Mac on this course, but feel free to use Linux or Windows, as the process is the same on all platforms. When you look at why Docker was created and why it is popular, it is mostly for its ability to reduce the amount of time it takes to set up the environments where our applications run and are developed. Just look at how long it takes to set up an environment where you have a Node and Express API for backend, which also needs Mongo, and then if you add your applications or front end, you may need to set up several pieces there too. And that's just the start. Then, when your team grows and you have multiple developers working on the same front and back end, and therefore they need to set up the same resources in their local environments for testing purposes. How can you guarantee every developer will run the same environment resources, let alone the same versions? All of these scenarios play well into Docker's strengths, where its value comes from setting containers with specific settings, environments, and even versions of resources, and simply type a few commands to have Docker set up, install, and run your resources automatically. And more often than not, much faster too. And these are the scenarios we'll cover in this course. So let's go briefly over the main components. A container is basically where your application or specific resource is located. For example, you could have the Mongo database in one container, then the front-end React application, and finally your Node Express server in a third container. Then you have an image, which is from what the container is built. The image contains all the information that a container needs to build a container, exactly the same way across any systems. It's like a recipe. Then you have volumes, which holds the data of your containers. So if your application are on containers, which are static and unchanging, the data that changes is on the volumes. And finally, the pieces that allow all these items to speak is networking. Yes, that sounds simple, but understand that each container in Docker have no idea of the existence of each other. They're fully isolated. So unless we set up networking in Docker, they won't have any idea how to connect to one another. So let's get started with Docker. So the first thing you need to do is installing Docker. And it's a very simple process, and just go to the main website, which is docker.com. And once you get there, there's a button that says Get Started. Click on that button and then scroll down until you see the Docker desktop. And then select the operating system you're on, download, and then install. Once you have that installed, you should see a whale logo or icon here, and that's basically Docker running. So if you see Docker desktop is running, that means that you're good to go. The other thing that I would recommend is to create an account and then make sure you log in with your account, because we are actually going to use some of the things that require you to sign in. So once you have that set up, let's move on to the next step. Also, most of our applications require a MongoDB database. So just to make sure, and if you want to test them as well, make sure you follow the instructions to install MongoDB. So how do you find them? You go to Google and you type MongoDB Community Edition, and then go to install MongoDB Community Edition. So once you have all this installed in your system, you're good to go. So let's take a look at what you have for the sample application. So let's go into the exercise files, and then click on Resource. And basically what you have here is 3 applications. You have one, which is a simple backend. The other one is a simple front end, so basically a React application. And then you have a full backend. And these are basically the applications that we're going to leverage for the course. We're going to start with the simple backend here, and we're going to leverage these applications with Docker. So if you want to explore them, this is the first application. It has a very simple database connection and an initial start of a server. Then you have the React application. If you're familiar with React, this is what it looks like. And finally, you have a full backend, which is basically an expanded version of the simple backend. But on this one, you actually have controllers, models, and routes, and all that jazz. Also, feel free to use your own applications. The goal of this course is not to learn how to build backends and front ends and these applications. The goal of this course is to learn how to use Docker with your applications. All right, so now that we have all that set up and are ready to go, let's move on. If you're looking for a crash course on Docker, this video and the next one is perfect for you, as we'll quickly put a Docker image and a container by using the backend project in the resources. So let's get to it. So the first thing we're going to do is create a brand new folder inside of our desktop and leverage the project that we have in the exercise files. So let's open the exercise files. Let's go to resources and then the simple backend. And I'm going to create a brand new folder right here. And I'm going to call this backend. Perfect. And then what I'm going to do is copy the files from the simple backend like so, and then paste them inside of this new backend here. Perfect. And close all this. And then we're going to open VS Code. In this case, if you're using anything else, that's fine as well. And I'm going to create two new files in this project. One of them is going to be Docker ignore. And Docker ignore is basically the file that tells you what you don't include in the container. So let's go ahead and do that. So I'm going to create the file and I'm going to call this .docker ignore like so. And then I'm going to basically add the node modules. I don't want to have those in the Docker file because it's going to automatically install them. So I don't want to include them if they're already there. And also the npm debug.log. Okay, so once we have that, we can save, we can close that file, and then we're going to work on the most important file for that project, which is the Docker file. So basically, the purpose of a Docker file is to create an image based on the instructions of your Docker file. So let's go ahead and create that Docker file like so. And let's make sure we install that. Perfect. So I'm just going to close that. And now that I have a Docker file, and let's go back here. Now, I wanted to show you guys that because there's an extension that helps you when you create the Docker file. So it kind of does a little bit of the suggestions and things like that when you create your Docker file. So install that extension if you're on VS Code. And if you're not, then install any tools that could help you with a Docker file. So once we are in the Docker file, we're going to go ahead and do the instructions for the image. So basically, every instruction that will include in that file will tell Docker, create an image from this, and then from the image, we're going to create a container. So what we need is node first, and then we're going to create a work directory and iCaps for everything, by the way. Well, not for everything, but at least for the instructions. And then the directory where we want to place all this. Finally, we want to copy the package.json file to our main directory. Then we want to run npm install. So we install all the dependencies that we have in our project, basically installing what's in here. Then we want to copy our directory from here to the actual directory of the container. So what does that mean is I have a file here and I would have other files if it was a larger project. So what you're doing here is asking Docker to copy the content of your application into the new container. Then finally, we want to expose the port that we need. So in this case, it's port 4000. If you don't know which port we're exposing, you can look into the index.js. In this case, it's right here. And then finally, we're going to run a command to run the application. And this is basically going to type the npm start command. Okay, so basically what we just did is create the file that will give the instructions to the image to create the image. And then from the image, we're going to create a container. And what you're looking at are the instructions. So let's move on. Okay, so now that we have a Docker file created for our test project, let's go ahead and create our image from it and test it. So the first thing you need to do is to make sure that Docker is running. So if you don't have that whale icon right here or wherever it is on your system, and when you open it, Docker desktop is running, make sure that it runs and that it's green. Once you have that, also make sure that you're signed in and you're good to go. So let's go ahead and open up a terminal inside of VS Code or whatever is the editor that you're using, or you can open up your own terminal separately. So what I'm going to do is go ahead and click on Terminal, New Terminal, or the shortcut Control-Grave. And the first thing we need to do is use the instructions that we have from our Docker file and create an image from it. So basically, take all of this and create your image. So let's go ahead and do that. So how you create an image is simple. So you do Docker build and then -t to name your image. And we're going to name it, well, at least me, I'm going to name it this way. So algo fields / simple backend. And you can name it anything you want. And once you're done, place a dot at the end. That's very important. Otherwise, that command is not going to work. So now what it's going to do is download the node image and then run every single command of your Docker file and create your image. Let me just clear that up so I have a little bit more state. So now if we want to check, do we have an image created? Let's go ahead and do Docker and then images. So this is going to list all the images that you've created. In this case, we have just one. And if you want to manage anything inside of Docker, you always use the IDs. So the images have an ID, the Docker containers have an ID, and when you want to manage them, you use the image ID. So let's say, for example, you want to delete this image, you would do something like Docker RMI, and then the image ID. And you can enter just the 4 or 5 first characters of this image, and then you would delete it. I'm not going to do that, but if I wanted to delete this image, I would literally hit enter and this image would be no more. Now, how do you run a container from this image? It's a very simple command. Again, how you do it is basically Docker. Again, always start with Docker. And then what you do is run. Now we need to specify the port. So in this case, we're passing port 4000 from the container to the application. So 4000, 4000. And then you want to tell it which image you want to use. So algo fields, simple backend. And as soon as you hit return, it's going to start your application or start your container from the image that you created. So basically, we're going to see the server running as if we were just running it locally. Now, if you want to manage this container, stop it, or do anything else, you need to open up another terminal. So I'm basically going to open a second window here, and I'm going to list the containers to see if my container is there. So the way to list containers is Docker PS. So as you can see, I have this container ID, which is simple backend, and it's running on these ports, and it was created 24 seconds ago. So if you want to stop this container, you can do Docker stop and then name the container. And if for some reason, sometimes the container doesn't want to stop or it has a process with another container, you can also do Docker kill and then with the actual Docker ID. So I'm going to do Docker stop, the FEE. And if it lists the FEE or the ID of your container, that means that it stopped. So if you want to check it, you can do Docker PS. And as you can see, it's no longer running. But if you have any issues, again, the Docker kill command is very useful. So now another command that you can use from time to time is Docker pull or Docker push. So if you're connected to your account here, so in this case, algo fields, I could actually push an image to Docker Hub. So I could do Docker push and then the name of the actual image. And you can also Docker pull the name of the actual image. And that's basically what we've done when we've included node in here. So it's pulled the actual node image and then added it to our own image. But there are a lot more commands if you want to learn about them on the actual website. And if you go to this link here, you're going to see all the commands that you can do within Docker, and then you can click on them and you can learn more about the syntax of using these specific commands. So most of the commands that you're going to use are the ones that we're exploring in this course. And if there is a specific function that you want to do and you don't know how to do it, you can do a search on the docs here and it should provide you with some answers. If you have a fairly good idea of how you'd split a full stack application, feel free to skip this video and get down to it. In this chapter, we'll take a look at how we do front-end, back-end, and then a full stack application with Docker. We'll first get started with a back-end on its own, and then move on to a front-end by itself, and finally, a full stack application. So feel free to skip to the part you prefer. In all cases, we'll build a container for all static assets, and also splitting the backend, front-end, and finally our persistence into its own container with a volume for the data/db directory. In other words, all items that don't need changing, such as the code of our applications, will be hosted in containers, and the dynamic pieces will need a volume in order to be able to host data. So with this brief introduction, let's get right to it and get started on working with our example apps. Okay, so now that we've seen how to work with a simple node and Express backend, let's add a little bit more to a similar project that has routes, a full API with endpoints, and a Mongo database, and see how this would work. In the process, we'll introduce Compose. Compose is a tool that allows you to manage multiple containers and set your entire backend with a single file. Let's take a look at what it looks like. So the first thing we're going to do is go into the backend we created previously, open it, and then delete everything but Dockerfile and Docker ignore. So you can delete this and then move it to trash. And then what we're going to do is go into the exercise files. And then from the resources, grab the backend right here. So copy all these files into this folder here. Let's go ahead and do that. Copy and then paste. Perfect. So now let's close those two. And then let's get back to VS Code. So I'm going to drag and drop this into VS Code here. And now we have our Docker ignore, Dockerfile, and the backend. So the file that we need to create to use Compose, it's called docker-compose, and it's a YAML file. So let's go ahead and create it. So I'm going to click on new file, docker-compose.yaml. Like so. So what we need to do now is tell the instructions for Compose to create whatever we want. So do we want a backend? Do we want a front end? And the YAML file will give those instructions. So let's go ahead and create it. The first thing you need to do is basically set a version. So in this case, we'll set it to 1. And then tell it what services you want for your application. So we'll start with app. So this is the service that we define as app. And inside of it, we'll have a container name. And for this one, we're going to call it app. Then we need to set a few instructions. So for example, restart always. So we're going to tell it to restart always, obviously. And then build. So you remember we need to do a dot when we create a new container. That's basically the dot that shows up here. Then set the ports. 4,000, 4,000. So as you can see, we're doing a lot of the same instructions that we've done when we built from our image a container. Then we're going to link it to Mongo, which is the next service that we're going to create. So basically, what I'm going to do is go back and then create the Mongo service. And basically, it's a lot of the same instructions that we have here. So what I'm going to do is copy up to build. It's going to be a lot of the same instructions, but let's go ahead and do it. In this case, this is called Mongo. So this is how this link to the Mongo container name here that we've created. And we need to pull an image for this one because we don't have that image or we haven't created that image. So basically this one will pull from the image or Docker file that we're creating. This one needs to pull it from Docker Hub. So this is why we're naming it here. Then Mongo needs volume. So we're going to create a volume for it. And then we need to specify the port. And pretty much like we've done here. So you can copy this line if you want. And then just change the port that we're going to define. So databases with Mongo are typically the 27017. And this is what we're going to insert in here. And then save. So as discussed previously, the containers are static and therefore don't change. So therefore, from Mongo's database, we introduce a volume which is dynamic and connects to the Mongo container. And then we use keyword links to be able to connect the node server to the Mongo container without doing complicated networking configurations. So we'll test this in the next video. Before we move on and test our new Docker backend with Compose, make sure you have shared local drives for the volumes that Docker will need. And the way to check for that, all you need to do is go into Docker and then Preferences. And then what you could do is go into Resources, File Sharing. So if you don't have anything like volumes in this particular resources here, what you need to do is create a volume because otherwise it's not going to work. So once you have that, you should be good to go. So let's go ahead and close that. Also, the other thing that you absolutely need to do in the index.js file is to make sure that you connect to Mongo here. Because if you don't connect to Mongo this way, it's going to be looking for that container name Mongo and it's not going to find it. So make sure that you're actually using this connection the same way. All right, so we're ready. So what we're going to do is bring up the terminal first. Let's go ahead and bring a new terminal. And obviously you need to make sure that Docker is running here. And the first command that you need to do in order to build all this, because as I said in the last video, we actually set the instructions here. So we basically said in this file what needs to be built, so we need to build it. So let's go ahead and do that. So the way to do that is by doing the command docker compose and then build. And this is going to build all the images, pull the images, and basically build all the instructions that we've set in that file so we can run all this later on. So once that is done, what we could do is basically go ahead and run it all. So the way to do this is do docker, compose, and then up. Now, if we do up, it's going to start everything at the same time. It's going to run into errors because basically the server or the app is looking for the database Mongo. So we want to make sure that the Mongo database actually runs first, and then we run the app and it's going to be looking for that Mongo connection. So the way to do this, as opposed to just do up, you need to specify which service you want to run first. So the way to do this is by doing -d and then the name of the service, in this case, Mongo. So let's go ahead and run Mongo. And if we didn't build a container first, it would actually build it right now. So if you want to check if that container is working, you can do basically the same command that we've done before, docker ps. And now you can see that Mongo is running. So now we can do the same for the app. So let's go and do docker compose up-app, like so. So now we have the Mongo and we have the app started. So if you want to check again, you could do the docker ps command, and you're going to see that now we have the backend and the Mongo application running. Now you can do a command to check if something is running, or you can check the logs of that specific application. So for example, if you want to check the logs of the Mongo container, what we could do is do docker logs and then the ID of that container. So in this case, it's C23, so on and so forth. So C23, D8. And now you're going to see basically the logs for that container. And you can do the same for the app. And let's just do a PS first, Docker logs, and then the ID number here. So in this case, we want to check the backend app, 365.6. And now you see the logs for that particular application. One more way to check all this, if you don't want to do it in the CLI, what you could do as well is go into Docker, the desktop app. So basically what you could do is click on the application, click on dashboard, and now you can see what's running. So you can see that we have a backend running with app and Mongo. You can also see the images that we created all through this. And finally, you can see the volumes that we've created. So we created a volume inside of our Docker Compose, and you can see the ID and the volume that we created. So let me just close that for a second. And if you want to check that the application is actually running, you can actually open your web browser and check. Let's go ahead and do that. Do localhost, and the port is 4000. And then you're going to see what the Node Express server is supposed to be saying. So as you can see, everything is running properly. The database and the Node application is connecting and everything is going. So let's say we wanted to stop all this, because right now we have a bunch of containers that are running. We want to stop all this. There is a command for that as well. So it's called docker compose stop. And by doing this, you're not just stopping one, you're stopping all of the containers. And now if you want to check, you can do a docker ps. You're going to see that nothing is running. So all the same Docker commands are also available for you to validate everything that is running properly in testing your items. So if you're looking at any of the Docker commands, you can actually check these containers, even though they've been started by Docker Compose. If you skip through all the videos related to backend, we'll take a look at what we need to get a front end up and running. In this case, a React application. If you've followed all videos up to now, you probably have a very good idea how to set up React with Docker, and feel free to test yourself on it. So let's go ahead and do it. So the first thing I'm going to do is go on my desktop and create a brand new folder called frontend. Let's go ahead and rename this to frontend. And then what I'm going to do is go into the exercise files and again, look into the resources and find the frontend. And you could have simply copied this file directly here, but let's do the hard work. So let's go ahead and copy that and then paste it inside of that particular folder here, like so. And then let's go ahead and add this into VS Code. Perfect. So it's the exact same process we went through when we created the Docker file and the Docker ignore file. So let's go ahead and create those two files. So the first one that we're going to create is the Docker ignore. Let's go ahead and do that. So .docker ignore. And then the Docker file. Okay, so we'll add the two lines from node _modules, exactly the same thing that we've done the last time, and then npm debug.log, and then save that file, and then move on to the Docker file. So the Docker file is slightly different, but most of the instructions are going to be the same. So we start again from, and again, I'm saying this to the people that actually watched all the videos before. If you haven't and you skipped all the way to the front end, this is basically what we're doing. So these are the instructions for Docker that are going to read through and then create the image. So the first thing that we're doing, we're telling it, pull the image from Node. So pull an image of Node from Docker Hub and then create the rest with it. So we'll need to create a working directory. And in this case, we're going to call this client. And then we're going to copy the package.json file. So basically this here to the directory client, like so. And then we're going to run npm install to install all the dependencies that we need. But we also need all the other files, because right now, if you read those instructions, we have this directory. We copied only this file, and then we ran npm install, but we still don't have the source. We don't have the public files. So we need to copy that. So what we're going to do is copy everything to the client directory, like so. And then we're going to expose the port 3000. And then once we expose the port 3000, what we need to do is do the command npm start. Like so. So once you're done, you save this file, and we're pretty much done for this video. What we're going to do is start all this in the next one. Okay, so now that we have a Docker file created for a React project, let's go ahead and create an image from it and then test it. So the very first thing that you need to do is make sure that Docker is running. Otherwise, it's not going to work. So you want to make sure that you check the icon at the top here and you have the whale with the containers on top. And if you want to make sure, you click on it and you'll see Docker desktop is running. So once you see this, you're good to go. And again, these are all things that I'm repeating for the people that actually watch the entire course. But if you're just coming in for the front end, this is brand new and I'm going to repeat a few things. So now that we have Docker running, all we need to do is take these instructions here and create an image. So what Docker is going to do, once we run the command, it's going to look for an image called node and then build our client folder and then so on and so forth. So let's go ahead and bring up our terminal and let's get started. So the first thing you need to do is build the image from the instructions from the Docker file. And this is how you do it. So you do docker build -t to name it. And then we're going to call this algo fields /front end. And then you want to make sure you add the dot at the end. If you don't add the dot, you're going to get errors. That is absolutely crucial for that command. Now that the image has been created, all we need to do at this point is to check, do we have an image called front end? Let's go ahead and check that. So the command for that is docker images. So right now we have all the images that we've created inside of this course, even the ones that we've leveraged with Compose. We have the backend app, we have Mongo, and we have the simple backend, and we have the front end that we created. One thing to note that is super important, everything works with ideas inside of Docker. So your images have ideas, your containers have ideas. When you want to manage the images or manage the containers, you use the ID for that. And you only have to type a few characters of that image ID because most of them are really different. So if I wanted to remove the backend app, for example, I would do a command like docker rmi and then the ID. So I would be basically doing 4111, and then it would know that this is the one that I want to delete. I'm not going to do that because we're going to leverage these images later on, but that's the command for that. So now that we have an image and we actually know how to delete it or list the images, let's create our first container from that image. And the way to do that is by doing docker run -p. And basically that command allows us to pass the port from Docker or the container to the application. In this case, we need port 3000. And if you followed the previous videos on the backend side, you would do 4000 for that. And then basically what images you want to use for that. So algo fields /front end. And then hit return. And it's going to basically create your container with this application. And now we have this application. So if you want to check that it's really working, you could actually open up a new browser window and then do localhost 3000 and you see your application running here. Now, let's say you wanted to check that this container is really working. It does work because we just checked in the browser, but let's say you want to stick to your terminal and you want to check it regardless. You can create a brand new terminal window and then check by doing docker ps, and this is going to list all the containers that are actually running. And in this case, we have the front end. If we had more, it would list all the containers that are working. You can also check this by going to the actual application, the desktop application. So by clicking on the icon here, clicking on dashboard, and now you're going to see that we have this application that is running. Now, when you're ready to stop the container, all you have to do is do docker stop and then the ID of that container. So in this case, 3051, blah, blah, blah. 3051. And that container has been stopped. If you want to check, you can do a docker ps again, and you'll see that the container has been stopped. Now, let's say, for example, you've stopped a container, and then you go back to the images, and then the image that is actually connected to that container, you want to remove it, and it gives you some sort of error. Can't really delete it because the container is still running. Sometimes what you could do is do something like docker kill as opposed to stop and the actual name of the IDE. Now it's going to tell me that nothing is running. Okay, but if it was running, then you could actually stop it that way as well. Now there's dozens of other commands that you can do inside of Docker. And if you're curious about it, these are all the commands that you can use with a Docker container inside of your CLI. And this is the link. So if you're curious about anything, you can actually click on the command and then take a look at what the command is and what it does and so on and so forth. So this is how you actually run a front-end container inside of Docker. Now let's put it all together. We'll put all of our different pieces into a single compose file and the files in their own directories. So let's get to it. So now we have a backend and a front end. Let's create a full stack. So we'll create a new folder, and I'm going to call this full stack. I'm going to open that folder and then create two folders inside of it. One is going to be called API, and the other one is going to be called client. So we're going to have our client and then our API in this folder. So all you have to do at this point is copy from the front end the files from the front end. So copy those files into the client right here, like so. And then we're going to do the exact same thing for the backend. So we're going to open the backend folder here and then copy all the file except the Docker compose file. So just remove that one, copy the files, and then put them into the API, like so. And then we're going to put the Docker compose file inside of the main directory. So let's copy that and then put it on top right here, like so. Well, now we have all the pieces. Now we need to code a little bit. So let's go ahead and basically open this folder inside of VS Code like so. And the first thing I'm going to do is make all the changes to the Docker compose file. So in previous videos, we've used version 1 of the Docker client / Docker compose. It actually is at 3.9 as of today. So this is basically the Docker engine that it's using. So basically the core engine of Docker. So we might as well use the latest one. So let's go ahead and do that. So 3.9, but it doesn't really matter for the previous videos because it was an example, but I wanted to really demonstrate what this is and when you're using different version of the engine. So what we're going to do is keep most of the things here for the app, but we're going to start using a few different things. So the build will now be API, like so. So basically, this is where we're going to have our build in the .api. So earlier was the dot, so basically at the top directory. And now we're actually using the API. So instead of doing links, we're going to change this to depends on, and then Mongo. For the Mongo container, we're going to keep this the same, image the same. We're also going to do a restart. Always. We're going to expose the port 27017. So we expose it to the external API. And now we're going to add the actual client. So let's go ahead and add that. So I'm going to put it on top because I'm going to go from front end, back end to the database. So let's go ahead and do that. So I'm going to do client, container name, restart always, build it inside of the client directory. Which ports we want to pass are the 3000 ports that we've actually done in the main command as well. And actually links to the main app. So once we've done the Docker compose file, what we need to do is go into the client file and make sure that everything in the Docker file works perfectly. So for the client and for the API. So you open up the Docker file. And for the API, now we're going to do just app. So basically what we want is to maintain the sort of structure app to client. So the client, the same thing. So if the client is already that way, then it's all good. So this is the Docker file for the app. And let's go ahead and open up the client as well. And the client is already in the proper format. So now that we have all the pieces, let's go ahead and start the whole thing. So it's basically the same thing that we've done before. So let's bring up the terminal first. So as we've done before for the backend, we do Docker compose. And the first thing that we need to do is build. And now it seems to be mentioning something. So let's just go and take a look just to make sure. Ports, and I forgot to put this as a list. There you go. And just want to make sure that everything else is good. This one needs to be like that too. Okay, let's save and let's go back to our terminal and we should be good to go. Docker compose build. And now what it's going to do, again, it's going to go through the instructions of the entire compose file, build all these images, pull the images that it needs. So for example, Node, Mongo, and then when it's done, we're going to be able to run all the containers. Okay, so now that we have all the images built, we need to run the containers. But again, if you haven't been exposed to Docker Compose before, if you haven't followed the backend exercises and videos, basically what you need to do, if anything links to something else, you need to make sure that this runs before. So if you did something like Docker Compose up, this would start the 3 services at the same time. So basically, if your API or your main app relies on the Mongo database, it would run into errors because your database hasn't been started first. So you want to make sure you basically select the services that requires to be started first. So in this case, we need to start Mongo. And the command for that is -d Mongo. So we're going to start Mongo, all good. Do the same for the app. So we have now Mongo and the main API running. And now we can do the same for the client. Up-client. And all our services are running. So if you want to check, you can do a Docker PS. And you're going to see that all 3 are running successfully. If you're running into errors, so let's say, for example, you've been following this entire course in one sitting, and you're seeing errors when you start Mongo. So basically, it's going to tell you something like, Mongo's already running. Well, one way to kill all this and kill all the containers and start from scratch is to go into the application right here, open up the dashboard, and basically stop or kill or basically delete anything that you have in here. So you can also manage your entire container stack right here inside of the application. But it's good practice to really get familiar with the commands because most people use the commands. And now we are going to stop this. So Docker compose stop, and it's going to stop all 3 containers. So this is basically how you put a full stack application with Docker. So you might be coming to Docker from another language. For example, you might be a Java backend developer focusing on Spring or a front-end developer focusing on WordPress and PHP. Well, the principles we've explored here are pretty much the same across all different types of projects. There are a few nuances, like, for example, the base image you use for your system where we insert the from in your Docker file. So for example, if we look back into our Docker file, this is from a node image. So if you do something for Spring, well, you would do something completely different. Fortunately for you, by following this course, even though you may not be a JavaScript developer, you'll have the base commands and what you'll need to create for your own projects. So let me show you a few resources where you can look for more information related to your specific scenario. So on that page, I would search for whatever type of project you're working on. So this is the Docker Hub, and you can access it through hub.docker.com. So let's say, for example, Spring. And these are all the images that are related to Spring. So all you would have to do is go ahead and click on it, copy the specific name of that image, and then go into your project and change it to that new image, like so. So it would start from that particular image and then create your application from there. You can also search on Google for any examples by doing Dockerfile, Spring, or let's say, for example, you're working on C# or a particular framework. You can basically search for anything you want. So Dockerfile, Spring Boot example is a good way to search for that and then getting started. And I would just look at the information related to that specific language. The same thing for WordPress. You just do a search on Google, WordPress Dockerfile, or even go back to the Docker Hub and find WordPress, and then you would find the instructions on how to build an image for WordPress. So this is how, if I was a developer for a different language or working with different frameworks, I would search for specific instructions on building for that application or language. The next step in your evolution as a Docker developer is to learn all about how to manage multiple containers, environments, etc. with Swarms or Kubernetes. Both tools are amazing, and you can take a look at both and then decide which one fits best for your style and needs. In certain scenarios, you can use both of them together. Let's explore Swarms first. Swarms is a tool from Docker and is enabled by default. This tool allows to cluster, manage, and schedule containers. So you could, with Swarm, manage one big cluster of containers. The machines in the Swarm can be physical or virtual and are then referred to as a node. In each node, you have your containers. So you could have multiple containers in a node depending on the resources available in the node. With a Swarm manager, you define and manage the entire cluster of nodes, which contains their own containers and could do load balancing across all your nodes. In this chapter, we'll be covering the fundamentals of using Swarms. But if you enjoy working with this tool, feel free to explore our library for more content on the subject. Okay, so now that we know about the basics of Swarm, let's go and create our first Swarm. So the way it works, you have the manager, basically the host machine that controls the Swarm, and then the workers. Let's put this into practice. You can use physical machines or virtual to create a Swarm. In this case, we'll use our host computer as the manager and then add virtual machines with Docker to the Swarm. So first, we need to create the node that will become the Swarm manager. So let's go ahead and bring up the terminal first. So I'm going to bring up a new terminal. And it's very simple. All you have to do is do Docker Swarm and then init. And basically that is going to initialize a Swarm for you. And that's how simple it is. So basically what you have here is the command to add a worker to the Swarm. So what you would do is SSH into the machine that you want to add to the Swarm. And then once you're actually in the machine, you could basically run this command and it's going to add that machine to the Swarm. You want to make sure that you have Docker installed on that machine as well. So right now what we did is a single node Swarm as opposed to multi-node. So when you do this internally in a machine like what we just did, you can only do single node Swarm. If you want to do multi-node Swarm, you need to have multiple machines, either virtual or physical. So now what we could do is do Docker info, like usual, and it's going to give you all the information on your Docker install and all the containers and the Swarms that you have installed. So if we look all the way up, you're seeing that we have 4 containers. 3 of them are stopped, 1 is running. We have 10 images. And then if we scroll down, you're going to see that you have a Swarm right here. So the Swarm is active. And then you have the node ID for the Swarm. And this is the master again, or the manager as they call it. And basically this guy will manage all the other workers that are added to the Swarm. So if you want to take a look at the list of nodes that you have, you can do the command docker node ls. So basically the same command that we would do if we wanted to list the containers. So docker ls, in this case, we're doing docker node ls. And now we see that we have one manager that is this particular ID here, and this is the Swarm. So as you can see, it's fairly easy to create a new swarm with a node. Okay, so now we have a swarm created. So you can add a node to the swarm if you want. When using the approach we just did, which is a single node swarm, you can deploy a stack to your swarm by leveraging the compose command. So let's say, for example, we wanted to add workers to the swarm we just created. You could literally go into the actual directory where you have a Docker compose file like this, and then basically add all these services to your swarm. So we could go in here and let's make sure we're in the right directory. We are, so we can see the Docker compose file. So you would do something like this command. So Docker stack deploy, and then the actual YAML file. So Docker compose.yaml, like so, and then name your stack. And this would create a stack for you. So if you have access to multiple machines, physical or virtual, you can add nodes to the swarm leveraging the command that was displayed when you initialize the swarm. So if we go back to the command that was shown earlier, like I mentioned, what you could do is SSH into the machine that you want to add to the swarm and then use this command. So that's basically how simple it is to add nodes to a swarm, either physical, virtual, or you can even use the Docker compose file to create a whole bunch of services based on the compose instructions. So when you have a swarm, you can also deploy services to the swarm and then inspect them to see what services you added to the swarm. So let's go ahead and do that. So what I'm going to do first is go and add a service to the swarm. So let's say you wanted to add a node server to the swarm. You would do a command like this: Docker service create replicas 1. And basically replicas is the number of these services you want to create or available. Then you would add the name of your service. And I'm going to call it node server 2 because I already created one. And then what is the image you want to add or use to create that particular service? In this case, I want to use the node image from the Docker Hub. And then you want to make sure that you can check where that image is coming from. So in this case, docker.com. So if I go ahead and do this, it's going to create a service for me. So it didn't take that long for me because the image was already in my computer. So basically just went ahead and created the service. And now if you want to check if that service has been created for you, you can go Docker service. And again, ls, which is basically the command that you want to do when you want to list stuff. And you have the node server 2 that has been created right here. And this is basically how you can actually get started with Swarm. And obviously, this is just a brief overview. And if you want to dig deeper with swarms, and there's a lot more to learn, you can either search for a course on swarms inside of our library, or you can take a look at the tutorials directly on the website. The next tool I'd like to explore that you'll often hear about is Kubernetes. Kubernetes is the standard in the industry and was built by Google and is open sourced. Also, at this time, it is much more extensible than swarms. It offers similar tools such as clustering, scaling, scheduling, and deployment. Kubernetes also uses the same concept of nodes for handling multiple containers, but the size of your network can build in the thousands of nodes if you need with Kubernetes. In the end, you select the tool that you prefer after you've had some experience with one or both. If you prefer to use a tool that is tightly integrated with Docker, go with Swarms. If you prefer to use an industry standard and more customizable tool, go with Kubernetes. As mentioned previously, there are multiple ways to get started with Kubernetes and learn all about it, such as courses in our library. So to get started with Kubernetes, go to the download section on the website's documentation at this link here. So if you go to kubernetes.io and then click on documentation, and then you click on getting started and then download Kubernetes. And if you scroll down, you'll have the installation instructions for Linux, macOS, and Windows. In this case, I'm using macOS. I'm going to click here and then scroll down. And I could go the manual way, but there's a much faster way with macOS if you have Homebrew. and the instruction is brew install kubectl. So basically, I'm going to copy this command here and then go to a terminal. And I just opened the macOS terminal and basically do that. And because I already have it installed, it may actually reinstall it with the latest version, but I'm just going to let it go. And actually, I had the latest and greatest. So I'm good. It may take actually longer for you, but in this case, once it's done, that means you have it installed. Now, what we need to do at that point is to first check to make sure that it is installed. So I'm going to do kubectl version and then dash client. Actually, 2 dashes. There you go. And basically what it's going to tell me is what is the version and so on and so forth. So if you see JIT version and build date and all that jazz, that means it has been installed in your system. Now, to use Kubernetes, we're going to use sort of an enclosed environment where you can actually test in your system, in your local system, commands from Kubernetes using a prepackaged tool that is called Minikube. So we're going to go and install that. So I'm going to go to the website. Once you're here, what you need to do is click on Get Started and scroll down and select again what operating system you have, what is the architecture, release type, and then you can do Homebrew or binary download. So once you selected all these things, on this case, if I do Homebrew, then I could do brew install Minikube, like so. And because I already have it installed in my system, it says, well, okay, so it's already existing. So, okay, we'll reinstall it again, but don't do that again. So let's move on. Now that we have everything installed inside of our system, we're going to be able to start using it in the next video. So now that we have Kubernetes installed, let's explore how you create your first Kubernetes cluster. Similar to Swarm, Kubernetes has a concept of a master who controls the nodes, and it is called control plane. And then the nodes are managed by this control plane. So in order to get started with your first cluster, make sure Docker is running first. And also you have Kubernetes installed. So if we look right here, I have Docker desktop is running, so I'm good there. And we actually installed Kubernetes in the previous video. So we should be good to go, and also make sure you have Minikube installed. So if you follow the previous video, you should have all of that installed and ready to go. So the way to start your first cluster is, again, very simple. So what you would do is Minikube, and again, we're using the control environment or the tool from Minikube, and this is going to create a cluster for us. And again, it might be a bit longer for you because you don't have all the images that it requires installed or downloaded to your system. In my case, I already have them all. That's why it took a lot faster. So once you have that, in theory, you should have a cluster started or a new cluster created. So let's go ahead and check. So the way to check for your cluster is to do kubectl cluster-info. And this is telling us that we have the control plane, which is the master like in Swarm, which is running at this address here. So this is the IP address that we could check and see that we have a control plane or the master for the cluster. And then you have core DNS is running at this address here. So now with this information, we could basically SSH into that cluster. We could add services and so on and so forth. Let's move on. So now we have our cluster created, but there's no application running on that cluster. So basically, we just have a bunch of servers that are clusterized together, but there's nothing running on it. So what we could do now is deploy an application or a service to the Kubernetes cluster. And the way to do that is basically by doing a simple command. So let's go ahead and do that by doing kubectl and then create deployment. And then you want to name the application that you want to create. So let's say node application. So we're pretty much going to do the same thing that we've done for Swarm by creating a new service with a node image. And we're going to add the application to the cluster by doing this command here. So then you want to specify which is the image that you're going to use. And in this case, I'm using the node image, which is already on my system. And boom, it's done. So what we just did is to deploy an application to the cluster based on the node image in Docker Hub. You can pretty much use any images from Docker Hub by adding it with the image tag. And if you want to use one outside of Docker Hub, enter the entire URL address. That is how easy it is. Let's say, for example, you want to add an image that sits on Google, for example. You would do something like this. So let's say, for example, the URL would be, and you need to do the full HTTPS or HTTP thing. So just copy and paste the URL from your browser, Google. Let's say, for example, Node, like that. Then it would pull the image directly from that website and create your application with that image. So we're not going to do that because there's not a /node application on Google. But now let's say, for example, you want to see what you've deployed to your cluster. You could do that by doing kube, ctl, get deployments. And as you can see, we have 2 node applications that are actually on our system and are ready to go. So as you can see, it's as easy as a few commands to deploy an application based on an image to your cluster. CI, or continuous integration, is crucial for the success of your application as you scale your users and functions. And Docker is perfectly built to handle CI with several tools at your disposal. Typically, CI is done with a process that resembles something like this. You develop new functions, commit them to a repo, and then the repo triggers a series of tests with a CI provider, like Travis, for example. So how can Docker help with such a process? For the purpose of providing a working example, we'll use Travis CI, which is free for open source projects if you want to test a workflow with me. A workflow involving Docker would look something like this. We first develop locally and commit our changes to GitHub, which then is connected to Travis and automatically tests our new code. And once the tests are successful, the new code is published to a third party, or in this case of the workflow we'll explore here, to Docker Hub. In this process, we'll leverage Docker images and other Docker tools to make it happen. You could also repeat the same process for development builds or production. So this is what this chapter is all about, how this entire process looks in practice. The first step in our process is to create a Travis YAML file inside of our project, so when we initialize CI with GitHub and Travis, the file automatically executes the testing. We'll also make some adjustments to our Docker file that we created previously. So let's go ahead and create our new folder for the new project, and I'll call this node. And then what I'm going to do is go into the exercise files, grab inside of the resources from the simple backend, these files right here, and paste them in that new project. The other thing I'm going to do is leverage the Docker file that we already created for a backend right here. And I'm going to grab the Docker ignore file and the Docker file, like so. Copy that, and then bring them into our node project. So if you don't see the Docker ignore file, it's probably because your system is not showing hidden files. So make sure that you show them and then select that file. Okay, so now I'm going to bring that project inside of Visual Studio Code. And then I'm going to open the Docker file. So the first thing we're going to do is make a few changes to the Docker file itself. So what I'm going to do, just above work directory, I'm going to run make dir and then do the usr source app. And this is just to make sure that we have all these directories before we actually work with them, because in Travis, we don't have that directory. So we want to make sure we actually create it first and then use it. We're also going to create an environment path. So let's go ahead and do this. And basically, the environment path exists in our system, but this is a brand new system, so it needs it as well. So let's go ahead and do that. Bin path, like so. Then you want to copy the packages to this directory. So we're going to copy that as opposed to this area. Then npm install, that's perfect. And then we want to copy from this directory into the new directory. So again, we're going to use the same directory. So basically, we're putting these files into the directory we just created. So we have the package.json file, we're installing all the dependencies, and then we're copying all the files that we have in here. And then we're doing pretty much the same thing, exposing port 4000, and then do the command npm start. Okay, so this is all good for that. Now we need to create the Travis YAML file. So let's go ahead and create a new file, and it's going to be called .travis.yaml, YML, like so. And this file basically is going to give commands to the Travis CI engine to actually run Docker and then build our application with the information that we have in this application here. So let's go ahead and do that. So we're going to do sudo first and make sure that it is used, so required. Then we're going to install our Docker service. And then we're going to run some scripts. So the first script is going to be Docker build. So we're building the image. And we're going to call this, and basically what you want to do is make sure that you put the proper name, because we're going to push that image to GitHub. So in this case, what I'm going to do is leverage and call this node, and then do Docker images, same thing. So we're building, and then we're using that image. Okay, so now that we have all these files created, let's move on. Now that we have our Travis file ready, let's go ahead and set up our repo in GitHub. Then commit our changes to this repo and initiate our Travis CI with GitHub. So the first thing we need to do is initialize Git inside of that project. And there's two ways you can do this in Visual Studio Code. You can do it in the terminal by running a command git init, or you can actually go here and initialize repository. So simple step. Once this is done, what we need to do to publish this project to GitHub, we need to create a remote repository and add it to this repo. So I'm going to go ahead and do that. So let's go into GitHub, and I'm going to create a brand new repository inside of my GitHub account. And I'm going to call this test node. And then as you can see, I'm already connected to Travis CI, but I'm going to show you how that works shortly. So let's go ahead and create repository. And now my repository is created. What I could do, because I have GitHub Desktop, is click here and then initialize it in GitHub Desktop. But we're going to use that a little bit later on in this video. I want to use the manual way by adding the remote with this address here. So you copy that, and then you go back to Visual Studio Code, and you go into the terminal command. So let's bring up our terminal. And basically the command you have to do is git remote, add origin, and then paste the address that we just added. And with that, we're going to add the remote repo to this repository here. But this is where I like to use GitHub Desktop, because this is actually helping with more complex stuff like merging, rebasing, pulling, conflicts, and things like that. GitHub Desktop is really good for that. So, for example, if we try to pull right now, there would be an issue because we have to rebase because we have a repo locally as well. But GitHub Desktop takes care of all of that. So let's go ahead and minimize Visual Studio Code for a second and bring up GitHub Desktop. So now I have a local repository connected to the origin or the remote repository. So I'm going to add this repository inside of GitHub Desktop by choosing it. And this is the repository that I want, the node. And now basically all I have to do is commit my changes. So I'm going to call this initial commit to master. And then I could go ahead and publish to branch. And now there was some issues, but GitHub Desktop took care of all this for me. And then if I go back to my repo right here, now I have all the changes ready to go. So now the next step that we need to go ahead and do is to see if Travis is connected to that repo. And we're going to do that in the next video. Now let's work on setting up Travis to see our Docker container being built, and then make a few changes and commit it to GitHub and see Travis rebuild and test our container. So the first thing you need to do is make sure that Travis CI is connected to GitHub. And then you can select which repos that you want Travis to test. So in this case, I already was connected to Travis. And as soon as I connect to Travis, I'm going to see the test node repo that I had on GitHub. But I'm going to get you through the process step by step. So let's go ahead and sign in first. And as you can tell, I already been connected here with GitHub. And basically what you need to do to connect is select your GitHub account, and then it's going to ask you to actually connect there. So as you can see, the test node repo has already been built and has passed the actual test. So if I wanted to rebuild it, I could click on restart build. But let's go into the settings to make sure that we have the repos that you want set up inside of Travis. So the way to do this is go into the settings. And what you want to do next is find the repo that you want tested on Travis. So for example, in this case, we want the test node, and it's somewhere in there. If you want to find it, you can actually look for it like that. And then as you can see, test node is here. Then we can click on settings, and then you're going to select if it's actually connected to Travis. So once you have that, you should be good to go, and you can actually go ahead and test it. But what we're going to do now is go back to this test right here. And what we're going to do is make a change to the repo or the code, commit it to GitHub, and then GitHub is going to push it to Travis, and Travis is going to test it again. So let's go ahead and do that. So I'm going to go to VS Code, make a tiny change here. So basically, I'm not going to make any structural changes or functional changes. I'm just going to change this one here. I love this Docker container. Okay, so now we have a change. We save it. Now we need to make that change with source control. So what I'm going to do is commit that change. I'm actually doing it here because I'm pretty sure there's not going to be any conflict like we had with the initial pull and push. So I'm going to commit that change and then update on string. And then I'm going to sync the changes. And if we're having issues like this, I'm going to go back again to GitHub Desktop. And we're good. So if we go back to GitHub and then take a look at test node, we have a second commit that has been done here. So we're good. And then we can go back to Travis and do a quick refresh. If you don't see the second commit right away, just refresh until you do. And this is what's going to happen here. And as you can see right now, it's testing the second commit, and we're going to see the result. You can actually take a look at all the terminal commands that are being run from what we've actually instructed in our Travis file, in our Docker files. Everything is done here. And then eventually it's going to tell us that it passed or it failed. And as you can see, it passed the second test. So as you can see, setting up a Docker container with Travis and GitHub is something that is fairly easy to set up.